Hey y'all, welcome back. On tonight's homework, we are solving word problems that have multiple equations. Number 1 says, Pat bought 9 pens from a bookstore. Some of the pens cost $2 each and the rest cost $3. If she paid a total of $23 for the pens, how many of the $3 pens did she buy? So if she bought a total of 9 pens from the bookstore, some of them cost $2 and some of them cost $3, let's construct a variable for each unknown here. So let's say X is the number of $2 pencils and Y is the number of $3 pencils. Okay, first it says she bought a total of 9 pens. So we have X plus Y equals 9. Next, she said she paid a total of $23 for all the pens. So if the X pens cost $2, we'll multiply 2 times X, plus the Y pens, these $3 pencils. Oh wait, they're not pencils, they're pens. Why did I call them pencils? $2X plus $3 pens for a total of 23. So here's our setup. And now we're going to go through the substitution steps to figure out what X and what Y are. So first, I'm going to need to rearrange this top equation. If X plus Y equals 9, then Y equals 9 minus X, if I just subtract X on both sides. Then I can take that expression, 9 minus X, and substitute it into Y for the second equation. That gives me 2x plus 3 times 9 minus x equals 23. And now I've got an equation that will help me find x, which is the number of $2 pens that she bought. Now you want to be careful because the question's actually asking for the number of $3 pens. So we might need to go back and solve for y eventually. 2x plus, and using the distributive property here, 27 minus 3x equals 23. Then I can combine my like terms here. 2x minus 3x actually gives me a negative x, and you're right to feel a little concerned about that, but trust me, this is still going to work out. Next, we will subtract 27 from both sides to give me negative x equals negative 4, and then finally divide both sides by negative 1 to get x equals 4. So there were 4. Remember, the X's were the $2 pens, but there was a total of 9 pens. So if 4 of them were the $2 pens, then 5 of them were the $3 pens. Number 2 says an investor has a total of 45 1-ounce ingos made of either gold or silver worth a total of $7,636.50. The value of one gold ingot, I'm actually not sure about that, is $280, and the value of a silver ingot is $4.25. Which system of equations can be used to find G, the number of gold ingos, and S, the number of silver ingos? So if the total is 45, so we've got a total of 45 ingos that could be either gold or silver. Just like on the previous problem where we had a total of 9 pens, our first equation should be, in this case, G plus S equals 45. And we see that in 2 of the answer choices. So right away, we can eliminate A and D from being options. Next, the total amount was worth $7,636.50. Well, this is kind of similar to how we set up the last one. In number 1, Pat spent a total of $23, and we multiplied each variable by how much that thing cost. So down here, the total should be the $7,636.50. This is really the only answer choice that has that, so does this one. Now I'm looking at these two, and the only difference here is one is plus and one is minus. But we're going to add these up. We're not going to count up all the gold ingos and subtract away the value of all the silver ones. So the answer here should be C. Number 3 says a taxi company A charges $4 plus 50 cents per mile. Taxi company B charges $5 plus 25 cents per mile. Which system best represents this problem? Okay, so the $4 is a one-time charge plus 50 cents per mile. And anytime you see this phrase, this per, whether it's per mile, per minute, whatever, that typically means you're going to multiply that number by x. So looking at these answer choices, I have 4 plus 50 cents x here, and really that's it. So our answer has got to be C. We can take a look at company B and just to make sure that the other one works too. We've got this one-time charge of $5 plus 25 cents per mile. So this is going to be the times x. So we got like 4 plus 50 cents times x and 5 plus 25 cents x. So yeah, the only possible answer here would be C. Number 4 says a humane society has 73 dogs and cats to be adopted. The number of cats is 10 more than twice the number of dogs. Determine how many of each type of animal is up for adoption. So let's break down the two equations that we need to set up. There's a total of 73 dogs and cats. So here I'll let D be the number of dogs and C be the number of cats. So D plus C has to be 73. It also says the number of cats. Okay, so let's break this down one little phrase at a time. The number of cats, that's C, that's equals 10 more than, so we're going to add 10 to whatever we have, twice the number of dogs, so 2D. Okay, now we've got our two equations. This is our system that we can use to solve for both C and D. Now one of the equations already has the C isolated, so I'm going to take that expression and substitute that into C for the first equation. So D plus 10 plus 2D equals 73. We can combine like terms, D plus 2D, to get 3D, plus 10 equals 73. Then we want to start using our properties of equality. Subtract 10 from both sides to get 3D equals 63. And finally divide both sides by 3. So the number of dogs is 21. So we've got one of the solutions, or at least part of the solution. We need to find the other solution, or at least the other part of the solution. So we've got this D equals 21, and we're going to substitute that back into D. It doesn't really matter which equation you put it in. I think this top one's probably easier to think about because it's got to add up to 73. So if we have 21 plus C equals 73, and we subtract 21 from both sides, we're going to get C equals 52, and that's the number of cats. So there are 52 cats, it's a lot of cats, and 21 dogs. On word problems like this, it's not a bad idea to go back and check your answers to make sure they make sense with the equations you originally wrote. So with the first equation, we said they added up to 73, and yeah, if you add these up, they do add up to 73. And let's test the second equation. If we double the number of dogs, that'd be 42, plus 10 is 52. So that one checks out as well. That gives us a pretty high degree of confidence we got this one right. Number 5, Sam is going to buy flowers for mom. Roses cost $2.50. Roses cost $2.50 and daisies cost $1.75. If Sam bought a total of 15 flowers and spent a total of $35.25, how many of each flower were bought? Okay, so I'm going to let R be the number of roses and D be the number of daisies. If there's a total of 15 flowers, then R plus D has got to equal 15. And then as far as the cost is concerned, each rose is $2.50. I'll just write 2.5, probably easier to write it like that, plus $1.75 per daisy. Oops, I got an extra 1 in there. Equals a total of $35.25. You're definitely probably going to want to use a calculator through this. I'm seeing the numbers with a bunch of decimals and stuff. Just have that calculator ready. So it doesn't really matter here which one you want to solve for first. I guess I'll just go for R. So I'm going to say R equals 15 minus D. I guess this is going to end up finding the daisies first. Now I think about it, but that's okay. We'll just go with that. We're going to take this 15 minus D and substitute that in for R right here. So I'll rewrite this as 2.5 times 15 minus D plus 1.75 D equals 35.25. We do have quite the equation here, so let's go ahead and use the distributive property. 2.5 times 15, that's something I'm going to do in the calculator. 37.5 minus 2.5D plus 1.75D equals 35.25. Then I'm going to combine my like terms, which are these two terms with the D. Negative 2.5 plus 1.75. Again, don't try to do all this in your head. Just type it in the calculator. Negative 2.5 plus 1.75 is negative 0.75. So now I've got 37.5 minus 0.75D equals 35.25. Now it's time to use our properties of equality on this two-step equation. I'll subtract 37.5 from both sides. 35.25 minus 35.7. Oh, I wrote that backwards. 37.5. Let's fix that. Is negative 2.25. So we've got negative 0.75D equals negative 2.25. And now I'll divide both sides by negative 0.75. So D will equal 3. So there's a total of 3 daisies, okay? And if there is a total of 15 flowers altogether, 3 of them are daisies, and the other 12 have got to be roses. So we've got 3 daisies and 12 roses. And that about does it for this homework. There weren't too many problems on tonight's homework. And honestly, on the actual TSI exam, you're not really going to get too many of these type of problems. So there will be 1 or 2 maybe, but they're not going to be a ton. So just keep practicing. Y'all doing great. As always, please reach out if you have any questions. But otherwise, y'all have a great night, and I'll see you next time.